Example 4, speed of two vehicles. So before it was one vehicle going and then coming back. Here there are two vehicles. And what usually happens is either the two vehicles are going towards each other, or they're going away from each other, or they're both going the same direction and one's trying to catch up. So those are the three kind of scenarios that you can have. So let's figure out which one we have here. Two trains are 550 miles apart, heading towards each other. So it's a scenario where you have train A is heading this way, train B is heading this way. Hopefully they're on opposite tracks so they don't crash into each other. Oh yeah, they're on parallel tracks, so they're not going to crash into each other, which is good. Train A is traveling 35 miles per hour. So we'll say 35 miles per hour. While train B is traveling 45 miles per hour. When will the trains pass each other? And that tells us our final answer is going to be about time. And it is probably going to be in hours. We might convert it so that it's hours and minutes. They think people care about that stuff when it comes to trains or buses, that kind of stuff. All right. How are we going to combine it together? Well, let's make a little table. Tables are good for organizing our information. So we got train A. Let's have a row for that. And train B. And we have rate, which is the speed, the time, the thing we're looking for, and the distance, which is actually rate times time, isn't it? All right. Now, let's fill in what we got here. The train is train A is 35 miles per hour. Train B is 45 miles per hour. Time, an interesting thing here, because we don't have anything about their time. They're going to cross each other after driving for the same amount of time. It's not like one train goes for an hour, the other one goes for an hour and a half, and then they pass each other. We assume they start at the same time. So we're going to use T for both of those. And the total distance, we're not sure what the total distance is for them, but we know how to calculate it. It's 35 times the time, or 45 times the time. We do know what those two distances added together are. So if we have distance of train A and train B, we know their sum should be 550 miles. Well, let's substitute these things in. Distance of train A is going to be 35 miles per hour times the time, plus the distance of train B, which is 45 miles per hour times the time, and those things added together should be 550. All right, let's simplify some things up here. 35 plus 45 is 80t equals 550 miles. Divide both sides by 80. And we get our time is 550 divided by 80, or 6.875 hours. Now, for most people, you would just say it in about 7 hours, right? Here, let's convert it so that we have minutes as well here, because it's going to be 6 hours. I just don't know how many minutes it's going to be. Well, the nice thing is, because it's set up in the decimal form here, I know that 0.875 is our number of minutes, but it's just written in hours right now. So I'm going to have 0.875 hours. Using dimensional analysis, I know there are 60 minutes in every hour. So 0.875 times 60, 0.875 times 60 is 52.5 minutes. And there is how long it's going to take for the two trains to pass each other.